Welcome everybody to another lesson in our unit on trigonometry. We are actually going to be taking a small break from our discussions of radians and arc lengths and central angles and so forth because in order for us to go or make our next move in this unit, we have to make sure that our knowledge of use of the trigonometric functions is solid. So these next couple lessons are basically going to constitute a review of trigonometry to make sure we have that good foundation, that knowledge foundation before moving on in this unit. So let's get to it. So first let's talk about what is trigonometry. So trigonometry is the branch of mathematics that studies the relationships between the angles and lengths of triangles. Namely, in most cases it's right triangles, not always right triangles, but in most cases it is. So we're going to be looking at the sides and angles of triangles, basically, and see how they relate to each other. Okay, so the first thing we need to do is we need to discuss the actual trig functions themselves. Now, there are 6 of them. There are 6 trig functions, though there are 3 main ones. Okay, so there are 6 trig functions, but there are 3 main ones. And when I say main ones, I mean these are the ones that you're going to see most of the time. These are the ones that you're going to use most of the time. The other 3 are, unless you're explicitly told to use them, you probably only need them in special situations. Okay, so once again, there are 3 main trig functions. Okay, so first, let's talk about a variable that you will be seeing a lot of going forward, a variable that is used a lot when representing a missing angle. Okay, so an angle that we do not know, an angle that we are trying to solve for. The following variable is used a lot when representing this missing angle. So the variable that I'm referring to is in the form of a Greek letter. As you know, mathematicians do like to use their Greek letters for variables, and the Greek letter that is used this time around is called theta. Okay, so theta, T-H-E-T-A, theta, or as you can see its symbol, it looks like a 0 with a line through it. Okay, so 0 with a line through it, so something like that. Okay, so that's your variable theta. So it is not a 0. Okay, that's important to note. Sometimes I've seen students make the mistake of thinking it is a 0. It is not a 0. It is theta. Okay, it is the variable theta. It is the Greek letter theta. Okay, so as you can see in this triangle, right? So that theta represents that angle in the right triangle. Okay, represents that angle in the right triangle. Okay, now before we discuss the 6 trig functions, one thing we have to get in the habit of is being able to label how these sides actually relate to the angle itself. So what I mean is the fact that each of these sides has a certain position relative to the angle. Has a certain position relative to the angle. So we're going to be labeling each of these sides, and this is actually a strategy that is very useful whenever using these trig functions in a problem. Being able to accurately, correctly label the sides label the sides in relation to the angle. So the easiest side to always label, because it never changes, the easiest side to label is the longest side of the right triangle, because the longest side of the right triangle is always going to be that side regardless of which angle you're looking at. So in this case, this is the longest side, and it is called the hypotenuse. Okay, it is called the hypotenuse. And another way to determine that, so not only is it the longest side, it is always the side opposite the right angle. Okay, it is always the side opposite the right angle. Okay, or on the other side of right angle, in other words. So that one's always easy. The hypotenuse is always going to be the same. It never changes no matter which angle you're looking at. And you'll see in a second what I mean when I say it never changes. So now let's talk about the other one. So since our angle is here, the side of the triangle that's on the other side, so that's on the other side to where the angle is, that is called the opposite side. Okay, that is called the opposite side of the triangle. Okay, that is called the opposite side of the triangle. So, because it is literally on the other side of where the angle is. And then the last one we have to worry about is called the adjacent side, which is going to be obviously the remaining side. So the adjacent side is always going to be the side right next to the angle. Okay, so the adjacent side is always going to be the side right next to the angle, not the hypotenuse side, because once again, the hypotenuse side is the longest side. So that's already been taken care of. But the side that is right next to the angle, that's going to be your adjacent side. So what do I mean before when I said that the sides are going to change relative to where the angle is? What I mean is that let's pretend, so I'm going to erase some of this. So let's pretend, okay, that instead of this angle, so I'm just going to put an X through that, let's pretend we were looking at that angle. Okay, so let's pretend that theta variable was in the top right instead of the bottom left of the right triangle. Well, in this case, our opposite and adjacent sides actually switch places. In this case, our opposite side actually ends up being over here, because that's the other side of where the angle is. And then the adjacent side ends up being over here, because that is the side right next to the angle. Okay, so you'll see the opposite and adjacent side switch places. And that is important to remember, because depending on which angle you're looking at, your opposite and adjacent sides will change. So you do got to be careful that if you're looking at a different angle than you were at the beginning, then you got to change your opposite and adjacent sides. Now, thankfully, the hypotenuse side never changes. The hypotenuse side is always going to be in the exact same position, or the exact same side of the angle, regardless of, the exact same side of the right triangle, regardless of where your angle is. But the opposite and adjacent sides can't change, so do take that into account. So let's stick with the original adjacent, and then this one was your opposite. Okay, so let's talk about the actual trig functions. So there's 6 of them. 3 of them you've most likely heard of in the past. The other 3, there's a good chance you've never heard of them. But once again, the other 3 are not as common as the first 3. So let's talk about the 3 main ones first. And once again, I call them the main ones because those are the ones that, those are the ones that you'll see the most and use the most, honestly. So the first one is called sine. Okay, it is written as S-I-N, but it is called sine. Okay, so once again, sine. So S-I-N-E, so don't call it sin of theta. Don't do that. It is called sine of theta. So just try to remember that. So once again, each of these trig functions is going to relate, or is going to equal a ratio of 2 sides of this triangle. It's going to be equal to the ratio of 2 sides of this triangle. So in this case, sine is going to be equal to the opposite side of the angle over the hypotenuse side of our triangle. Okay, so the opposite over hypotenuse. So it's going to be equal to that ratio. So whatever the opposite and hypotenuse sides of this triangle are equal to, that would be your ratio. So that's sine. So the next one is called cosine. So it is written as COS, but once again, don't say cos. It is called cosine. So cosine of theta. Okay, cosine of theta. So in this case, it is going to be the adjacent over the hypotenuse this time. Okay, so that's going to be our ratio for cosine. That's going to be the ratio for cosine. And now we have the third one, which is tangent. So tan. Okay. And that is going to be equal to, so tangent. So it is written as tangent. It is written as tan, but it is read as tangent. So this is going to be opposite over adjacent. So those are the 3 main trig functions. Those are the 3 main trig functions. Those are the ones that you're going to see the most. Those are the ones that you're going to use the most. But let's talk about the other 3. The other 3 which you might have never heard of up until now, honestly. And outside of special situations, you're probably not going to be using a lot of, to be honest. So sine, cosine, and tangent. Those are the three main ones. So the other three are what we call reciprocal functions. So think of them as, they're basically the same thing as sine, cosine, and tangent, but they're literally the flip or the reverse, or they're literally the same ratio, just upside down. Okay? So each of them has their own reciprocal function. So sine's reciprocal function is called cosecant, or CSC. So cosecant or CSC. And that is going to be literally, once again, the same thing as sine, just upside down. So instead of opposite over hypotenuse, it will be hypotenuse over opposite. And so literally it's the same ratio, just upside down, or you just flip it. Okay, so once again, that is cosecant. So cosecant, that's how we write it. That's how it is called. Okay, so it's not ksk, or I don't know how you would try to read that, but it's called cosecant. So the next one would be secant, and that would be the reciprocal of cosine. The reciprocal of cosine. So hypotenuse over adjacent this time, because cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. Okay, so it would be secant. That's how you would read it, secant, or secant. And then finally the last one, and the last one is typically the easiest one to remember. The last one is called cotangent. C-O-T, so cotangent, and that's going to be the reciprocal of tangent, so adjacent over opposite. And once again, I say it's usually the easiest one to remember because it's literally, it literally has tangent in its name, so it's a little bit easier to remember that is just the reciprocal of tangent. So those are your 6 trig functions: sine, cosine, tangent, those are the 3 main ones. Cosecant, secant, cotangent, those are the 3 reciprocal ones. And once again, cosecant is the flip of sine, secant is the flip of cosine, cotangent is the flip of tangent, the upside down version, in other words, the reciprocal. So those are your 6 trig functions. So these are the 6 trig functions that we will be using in the future whenever trying to determine a missing side or angle of a right triangle. Okay? So let's look at our first example. And in this first example, we're basically just going to be identifying what the ratio is. That's all we're doing. In this next example, we're just going to be doing the ratio of the sides for each of these 6 trig functions. So here we have example 1. So find the values of all 6 trigonometric functions of the angle theta. Okay, so just like I said previously, it is a very good strategy to label the sides of the triangle. Label the sides of the triangle. Which side is the hypotenuse? Which side is the opposite? Which side is the adjacent? Now, some of you with time are going to be able to, just keep that in your memory as you're working on the problem. But for some of you, it might be a good idea to write it down just in case you forget. So let's do that first. Let's write down which sides are which. Okay? So once again, the hypotenuse is always, or hopefully should be, the easiest one to identify because it is literally the longest side of the triangle, or the side opposite the right angle. Okay, so the right angle, the other side of the right angle. So that's the hypotenuse. Once again, the side that's on the other side of the angle, we call the opposite side. And the side that is right next to, even though at this point, by process of elimination, that is called the adjacent side. Okay, the side right next to the angle is called the adjacent side. But remember, if our angle was over here, the opposite and adjacent side would be flipped. They would have their places reversed. So just, once again, keep that in mind. All right, so let's do the 6 trigonometric functions. So let's do sine first. So remember, sine was opposite over hypotenuse. So in this case, our opposite is 4. Our hypotenuse is 5. That's it. That is the ratio for sine of theta. We're done. That's all it was asking us. Find the value of the trig function. We found the value. It's 4 over 5 for sine. So now let's do cosine of theta. So recall that one was adjacent over hypotenuse. So in this case, our adjacent is 3, our hypotenuse is 5. Next is tangent of theta. That one was opposite over hypotenuse. So in this case, it would be 4 over 3 because the opposite side is 4, adjacent side is 3. So now let's do the reciprocal ones. Now let us do the reciprocal ones. So the reciprocal ones, we had cosecant. That is the reciprocal of sine. So it would be hypotenuse over opposite. So that would be equal to 5 over 4, or 5/4, because it would just be 4/5 upside down. Next one, we had secant of theta, which is the reciprocal of cosine. So hypotenuse over adjacent. So 5 over 3 instead of 3 over 5. And then finally we had cotangent, which gave us, did I write? Whoops, sorry about that. For tangent, I wrote opposite over hypotenuse. That should say opposite over adjacent. Opposite over adjacent, okay? So we got, what is it? So adjacent over opposite. So that would be 3 over 4. So those are our 6 trig values. Okay, once again, a trig value is just a ratio of 2 sides. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, so on and so forth. So that's it. That's all you have to do for example 1. So this was just practice of being able to, being able to determine the ratios based upon the side. And now let's see. Now let's establish the same ratios in the next problem, but use the equation to actually solve for a missing side or angle. Okay? So let's look at example 2a. So example 2a says solve for the indicated side, so x, round final answer to 3 decimal places. Okay? So we're going to try to solve for x, given the information that we have using one of the 6 trig functions. All right. Now, like I said, label the triangle. Label the triangle. It helps. Trust me. It helps to label the triangle. So let's do that. So once again, the hypotenuse is the easiest one because it is the longest side of the triangle. And it is, once again, always the side that's on the opposite side of the right angle. Okay? All right. Well, let's see. Well, the side right next to the 37 degrees, is the adjacent. Okay? The side right next to the 37 degrees is the adjacent. And then by process of elimination, this side has to be the opposite, which makes sense because that is on the other side of the angle. So on the other side of the angle. Okay? Hypotenuse, adjacent, opposite. So opposite. So let's think about this. We're trying to solve for x, which is the hypotenuse side. We know the adjacent side, which is 11. So think about it. Which of the trig functions involves adjacent and hypotenuse? Okay, which of the trig functions involves adjacent and hypotenuse? And the answer to that question is cosine. Cosine involves adjacent and hypotenuse, so we should probably use that trig function. Now, we could also use secant, honestly, because secant is hypotenuse over adjacent, but we're going to use cosine because, once again, we know the adjacent, we're trying to solve the hypotenuse. It doesn't make sense for us to use the opposite because we're not trying to solve for it, right? And we don't even know it, okay? So hence, we don't, doesn't really help us there. So cosine. Well, we're doing the cosine of what? Well, we're doing the cosine of the angle, which in this case was 37 degrees, right? That was the angle that we looked at to determine the adjacent, opposite, and hypotenuse side. That is the angle, so that's how you're going to know the angle that you put inside each of the trig functions. The angle that you put inside each of the trig functions is determined by which one were you looking at when you were determining the opposite, adjacent, and hypotenuse sides. Okay, that is the angle that you're going to be plugging in. So we said that cosine is adjacent over hypotenuse. So adjacent is 11. Hypotenuse is x. Okay, so we just set up an equation. Cosine of 37 degrees is equal to 11 over x. Cosine of 37 degrees is equal to 11 over x. So we need to solve for x. We need to get x by itself, okay? typically when you have fractions, right, so 11 over x, that's a fraction, that's a ratio. Typically when you have fractions, you want to try to get rid of that denominator. So let's get rid of that denominator by multiplying both sides by x. Okay, right? If our denominator was 7, we would multiply both sides by 7. Okay, so just because it's a variable doesn't mean we can't cancel it out. Okay, so that cancels out. So that means we are left with x times cosine of 37 degrees is equal to 11, right? Because that denominator canceled out on the right side. Well, remember, we're trying to get x by itself. Well, the only thing next to the x is this cosine of 37 degrees. So if we want to get x by itself, let's divide both sides by cosine of 37 degrees. Okay? You can do that. You can divide both sides by the respective trig function to get rid of it. So in this case, now one thing you can't do is you can't say, well, I'm going to divide by cosine, but I'm going to leave the 37 there. No, the cosine and the 37 are together. They represent one term, one value. Okay, cosine doesn't mean anything if you're not taking the cosine of something. So that 37 and the cosine are, what's the word I'm looking for here? Attached at the hip, basically. All right, so that cancels out that, and we are left with. Oh, did I just do the exact thing? Yeah, I didn't. That's okay. The colors. That means x is equal to whatever 11 divided by the cosine of 37 degrees is equal to. So if we just plug it into our calculators at this point, there isn't much else we can do by hand. If we plug in 11 divided by the cosine of 37, all right, we should get, rounded to 3 decimal places, 13.773. So 13.773. And that is what x equals. So that is what the missing side of that triangle is equal to, 13.773. So once again, label the triangle, determine based upon what you're trying to solve for and what you're, given, which trig function to use, and then just get x by itself at that point. So that's 2A. So now at 2B, we have a different triangle. So this one I do want you to try on your own. Okay, so on your own, okay? So you might have to use a different trig function for this one, which is why I tell you label the triangle. Label the triangle, see which trig function would be most appropriate based upon what you're trying to solve for and based upon the information that you're given, okay? So that's 2B on your own. So now let's look at a different situation, because when you're solving for a side, your strategy is basically the same. Determine which trig function you're using, and then from there just get the variable by itself. Now, when solving for angle, we have to do something a little bit different. And you'll see here. So example 3A, solve for the indicated angle. Okay, so as you can see, the indicated angle, we have theta, right? Looks like a 0 with a line through it, but it is not 0. Like I said, it is the Greek letter theta. Okay. But the first step is we're still going to label it just like we did previously. So we're still going to label this as the hypotenuse because that is the biggest side. Once again, the side next to the angle is the adjacent side. And that leaves the side on the other side as the opposite side. Okay? So the adjacent side, once again, is the side next to the angle. Hypotenuse is the longest side. Okay, the longest side, and that means the opposite side is going to be the side on the other side of the angle. Okay, so let's see what we have. So we know the adjacent side, we know the opposite side. So let's think about this. Which trig function uses the opposite and adjacent side? So if we look back, we would see that tangent uses opposite and adjacent in its ratio. Cotangent also does, but once again, typically we use sine, cosine, and tangent, but you could use cotangent, nothing wrong with that. Okay, so tangent, what is our angle? What is the angle that we looked at when determining the which one was opposite, which one is adjacent? We looked at theta. So that is our angle. That is the angle that we're taking tangent of. So that's going to be equal to opposite over adjacent, so 11.9 over 10. 11.9 over 10. Okay. Well, do you see what's the issue here? the variable that we're trying to solve for is inside of a tangent, right? It's tangent of theta. Remember, theta is a variable. So how do we get that by itself? How do we get that by itself? Well, remember what I told you in the previous problem. You can't divide by a trig function. Or you can't just say, well, I'm going to get rid of tangent. I'm going to do this. I'm just going to divide both sides by tangent, and then theta will be by itself, right? Because that cancels out. No, you cannot do that. Once again, the tangent and the theta are together. They are one value. They are one term. There has to be a way to cancel it out then. There is. And it's a convenient trick, not a trick, but a convenient step. If you recall in our previous unit when discussing exponential and log functions, we eventually got to this point where we saw if we wanted to cancel out an exponential function, we had to do the inverse, right? We had to do the inverse of the exponential function, which was a log, right? We had to use a log. We had to use an entirely new function so that we could take the inverse and actually cancel it out. Well, the same thing happens here. We're going to be using an entirely new function to cancel out tangent so that theta is by itself. Well, what is the inverse to a trig function? Well, at this point, it's actually pretty convenient. The inverse to a trig function is literally just the inverse trig function. So the inverse to tangent is literally, because that's what we want to cancel out, the inverse to tangent is literally tangent inverse. Remember that because if you recall that little -1 means that's the inverse, so we're literally going to take the inverse tangent of both sides. The inverse tangent of both sides of this equation. Hope I gave myself enough room yet. And that is 11.9 over 10. Okay? So once again, if you want to cancel out a function, much in the same way if you want to cancel out multiplication, you have to do the inverse, which is division. If you want to cancel out a trig function, you simply just do the inverse trig function. Okay? Because in this case, we want the variable that we want to get by itself is inside a trig function. Okay? So, because they're inverses of each other, they cancel out, right? That's the whole point of inverse functions. They just reverse each other, so they're just going to cancel each other out. So that means on the left side of the equation, we're just left with the variable by itself, which was our goal. And on the right side of the equation, we're left with tangent inverse of 11.9 over 10. And that is actually something you can just plug into your calculator. So if I were to take out my calculator and do inverse tangent of 11.9 divided by 10, there's an inverse tangent button, okay? So you literally just have to press the inverse tangent button. You should get an angle, rounded to 3 decimal places, of 49.958 degrees. So 49.958 degrees. So that is the missing angle of that triangle. That is what theta is equal to, rounded to 3 decimal places. And yes, obviously, if you want to cancel out sine, inverse sine. If you want to cancel out cosine, inverse cosine, so on and so forth. Each of the trig functions have their own inverse function. Okay, so in this case, we wanted to cancel out tangent, so we use the inverse tangent. Okay, so that's what you would do. That's what you do in problems in which you have to solve for a missing angle. Problems in which you have to solve for a missing angle is you would just use the inverse trig function to cancel out the whatever trig function you ended up using so you can get that variable by itself, which is on the inside. Okay, so that was example 3A. So in example 3B, you're basically going to be doing the same thing, except once again, you're going to be doing this on your own. So label the triangle. Try to see, based upon the information that's given, which trig function would be most appropriate. In the previous problem, it was tangent. In this one, it will be a different one. I will tell you off the bat, it will be a different one. It's not going to be tangent again. And then you go from there. One more problem. Example 4A. So this is an interesting one. So this is unlike the previous two that we did. This time we are given one of the trig values. We are told that the sine of theta is equal to 7 over 25. We're told that the sine of theta is equal to 7 over 25. And then we're told to find the values of the other ratios. At first, given a problem like this, you might have no idea where to start. Well, let's think about this. Remember what sine is equal to. Okay, sine is equal to opposite over hypotenuse. So in other words, what this problem has given us, is this problem has told us that the opposite side of our triangle has a length of 7, and the hypotenuse of our triangle has a length of 25. So we can actually draw us our triangle here. Probably not going to be drawn the scale, but right, we can put our angle here. It doesn't actually really matter where we put our angle, as long as we don't put it at the right angle. And the hypotenuse of this triangle will be 25, so hypotenuse. And the opposite side of this triangle would be 7. Because it is on the other side of the angle. Other side of the angle. Well, the question is, how do we find that third side? How do we determine what the adjacent side is? Well, if you recall, in order to determine, if you're ever given two sides of a right triangle, which in this case we know 25 and 7, whenever given two sides of a right triangle, and as we covered in the bell ringer, in order to determine the third side, you have to use Pythagorean theorem. So we're going to be using Pythagorean theorem to determine that third side, the adjacent side. So let's do that really quickly. So Pythagorean theorem, a squared plus b squared is equal to c squared. So remember, c is always the hypotenuse. So we have a squared plus 7 squared is equal to 25 squared. So a squared is equal to 49. A squared plus 49 is equal to 625. Subtract 49 from both sides, because remember, we're trying to get a squared. A squared is equal to, what is that, 576. If we want to get rid of the square, we have to square root both sides. So if we square root both sides, we end up with a is equal to 24. So that is what the adjacent side is equal to, 24. Okay? So now we can do the other 5 trig ratios. So let's do that. So let's do cosine. Remember, cosine is equal to adjacent over hypotenuse. So adjacent is 24. Hypotenuse is 25. Now let's do tangent. Tangent is equal to opposite over adjacent. Opposite is 7. Adjacent is 24. And now let's do the reciprocal functions. So remember, cosecant is the reciprocal of sine, so it would be hypotenuse over opposite, so 25 over 7. Secant is the reciprocal of cosine, so hypotenuse over adjacent, so 25 over 24, or you just flip cosine, basically. And then cotangent is the reciprocal of tangent, so you just flip tangent, so 24 over 7, because that is what adjacent over opposite is. And that's it. So as you can see, this problem is a bit different. This problem is more similar to example 1, where we just had to determine all the different trig ratios, except this time we were given one of the trig ratios already, and we had to do a little bit of math before we could find the other 5, right? So we had to do the Pythagorean theorem before we could find the other 5. All right. So once again, example 4b will be just like the previous one, except this time I tell you what tangent is equal to. So you're going to draw your triangle, you're going to do the correct sides, which in this case is opposite over adjacent, and then you're going to use that to find the third side, and then finally the other 5 trig ratios. Okay, so this one is also going to be another one on your own. All right. Cool. So that is it for today's lesson. So once again, make sure you do try out those 3 problems that I told you to do on your own. But otherwise, as usual, let me know if you have any questions, or if any questions popped up as you were watching the video. Just leave me a comment in the classroom as usual. Otherwise, I hope you guys stay safe.